Good morning, everyone, and welcome to today's lecture. This is, I think, lecture number 3 on rotation, right? Or is it 2? I think it's lecture number 3 on rotation. We are dealing with moment of inertia. In the previous class, we had seen some question on moment of inertia. Do we remember? We had found out the moment of inertia of some composite bodies which had more than one body. We had two rods, we had three rings, and all that. Do we remember this?
Yes, sir.
Well, let us continue on this and finish moment of inertia, and then we can probably move on to other questions involving other topics. Let me just give you one or two more questions which I think can come. So I saw a question here. This is question from one of the previous JEEs, and let's see if you can solve this. It looks like the question that we have done before. Let's see if you can do this one. Uh, yes, this is the question that I was talking. Let I be the moment of inertia of a uniform square plate about an axis that passes through its center and is parallel to one of the sides. CD is a line in the plane of the plate that passes through the center but makes an angle theta with the line AB. What is the moment of inertia of the plate about the axis CD? I think we did a similar question in the last class. This is a question on plate. We did a question on rods. I had a rod and I had taken an angle. Remember the last question that we did? This one. I had made an axis at an angle theta. And now this is a plate which has an axis which is inclined at an angle theta. If you want, I can show you the diagram. Though diagram is not a part of the question, but still I will show you a diagram. This is one of the previous year's question. So very likely it may definitely come in the exam. So the diagram looks like this. What will be the moment of inertia of this plate about an axis inclined at an angle of theta? Yes, I'll give you 2 minutes to think about it. Yes. What is the answer? No idea?
No, sir.
You remember this question, yes or no? And I told you how you can have done this. Do you remember how did I tell you to do this?
Yes, sir.
How?
Substituting theta, sir.
If you put theta, answer should be? If you put theta as 0, answer should be?
0.
If you put theta as 90, answer should be?
I, yeah. I, sir.
What is the answer in this case? And the answer is?
A.
There are different ways in which you could have done this. That's why that method I told you. If you put theta as 0, answer should be I. If you put theta as 90 again, it is a square plate. Any diameter is same. The answer should be I. Both cases, the answer should be I. So there cannot be anything that fits this criteria. Answer is I. The other way to understand this, if you take this axis, inclined at an angle theta, this axis is also inclined at an angle theta. These are two perpendicular axes. The moment of inertia should be same. Yes or no?
Yes, sir.
Moment of inertia about I, about CD, and moment of inertia about C dash D dash should be same. Moment of inertia about AB and A dash B dash should be same. And if you add AB and A dash B dash, you should get moment of inertia along this axis. If you get CD and C dash, you should get moment of inertia about this axis. That means moment of inertia about this axis C dash should be same as this axis because there is symmetry in the figure. Do we understand this, or this has gone above our heads?
Understood, sir.
Use your brains when you are doing a question. If you do something that you must remember, give you 2 minutes to note this down. Remember what you have done. Otherwise, there is no point of doing all these things. If you don't remember, it will go waste. You cannot let it go waste. I hope you understand this. Yes or no?
Yes, sir.
So remember things. Okay. Let us move on to the next question. Now, this question is going to be put in a different number of ways. Let us solve it by one way, and then we can understand what are the different ways in which that a question could be put. So this is a disk with a hole. This is a disk with a hole. This disk has a hole of radius r by 3. Now, there are various ways in which the mass of the disk can be given. Now, the mass can be given as mass of the original disk. Mass can be given as mass of the remaining part that is remaining. So there are two ways in which you can, depending on which mass is given, the answer would be different because mass would be different. But let us solve this question in the most general way. Let us say that the mass density is sigma. You understand the meaning of sigma?
Yes, sir.
What is sigma?
Mass density.
What do you mean by mass density?
Mass mass per unit area.
Mass per unit area. So this is the most general way. Now you can find out this mass per unit area depending on mass per unit area will remain same. So we'll solve this question in terms of mass per unit area, and then you can convert this mass per unit area into the mass of whatever mass is given to you. So mass per unit area of this disk is sigma. You have to find the moment of inertia about an axis passing through O and perpendicular to the disk. Moment of inertia of this disk with a hole about an axis passing through the center of the disk perpendicular to the plane of the disk. Remember, we found the center of mass of this body also. Do we remember this? We apply the same concept here. I'll give you 2 minutes to think about it. Are you able to do it or shall I do it? Hmm? Are you trying? Shall I wait or shall I do it?
Say, sir.
What have you done? What have you tried?
Sir, I have taken mass as pi r square into sigma
Of what?
for larger disk
Okay.
with r, and I have calculated the moment of inertia of the larger disk with whole mass and subtracted it with that smaller disk with same mass, same mass density.
Okay. Did you get the answer? Hmm.
Sir, I got it like 40 mr square by 81.
This is disk 1, the complete disk without the hole. What is the moment of inertia of disk 1?
mr square by 2.
Mr square by 2. And m is how much?
Sigma pi r square
Sigma into pi r square.
into r square by 2.
This is the second disk. What is the moment of inertia of the second disk?
Sigma pi into r by 3 whole square into r by 3 whole square by 2. And I have subtracted them both, sir. M1 minus M1 Mi1 minus Mi2.
Moment of inertia depends on what?
Mass distribution of mass around the axis and shape and size of the body.
And Why did I get so many different answers in this question? Why 3 different answers in this question? 1, 2, 3. Why there were 3 different answers?
Distribution of mass around the axis.
Why there are 2 different answers here?
It is also same there. Distribution of the mass around the axis.
What is point number 3?
Axis of rotation.
Hmm. About which axis is this moment of inertia? Which axis? This moment of inertia is about which axis?
Around the center of that small pole.
Which axis we had to find out the moment of inertia?
At O.
Is it the same?
No, sir.
What, sir? Then what have you done, sir? You must do something else, right? What is that something else that you need to do? You have to use which theorem? You have to use which theorem?
No, sir.
Okay, I'll give you 2 minutes. Yes, bacha, could you do this or not? Just wait.
Sir, it is 4/9 MR square, sir. Hello, sir.
Could not do it? So, the distance between these two is 2r by 3. Do we understand this? So, plus sigma into pi into r by 3 ka square, which is the mass, multiplied by 2r by 3 ka square. That is the moment of inertia of this hole about that point. And this is made up of negative mass, so we'll put a negative sign here. You subtract the 2 and you will get your answer. Do we understand this?
Yes, sir.
Now, many a time this sigma may not be given. Remember, when this question comes, this would be a question where a lot of mistakes can be made. Why a lot of mistakes are possible? Because sometimes they will give you mass of this disk. Sometimes they will give you mass of this remaining disk. You don't have to use sigma. Or in that case, if you use sigma, sigma will become m divided by pi r square. In most of the cases, I've seen question where they give you the mass of the original disk. Now, if they give you mass of the original disk, then sigma into pi r square becomes the mass of the original disk, and then you can find out the mass of the remaining portion. It is r by 3, so it will be m by 9. Do we understand this?
Yes, sir.
So that way the question looks a lot simpler than this one. So now I'll give you that question. I will make this question and then you do it again. Now this is a sphere. This is a sphere now, sphere with a hole. Sphere with a hole. Do we understand it? This is a sphere with a hole now. Not a disk, but a sphere. Mass of the original sphere without the hole is m. Sphere of mass m. Original mass is m. The original mass of the sphere is m. Do we understand this? Now r by 3 radius has been taken out. What is the moment of inertia of the remaining of this structure about this point? Remember how the question is framed. Mass of the original sphere is given as m. Okay, now find the answer. Do you understand this? There are two ways in which this question can be given: mass of the original thing or mass of whatever is remaining. Both the case answer will be different because mass will be different. Yes. Shall I help you? If you're taking so long, that means you're not getting the answer. So I'll do it now. So first, the body is this sphere. What is the moment of inertia of the sphere?
2/5 mr square.
M1 is 2 by 5 m into r square. Then I find out the moment of inertia of this body. Body 2, moment of inertia. 2 by 5. What is the mass of this body? The mass of the original sphere was m. What is the mass of this body? This is not a question of physics. This is a question of common sense. If the mass of the entire sphere is m, what will be the mass of this radius r3 taken out from the sphere? It will be m by 27. Why will it be m by 27? Why? Chalo, think about it. Into the radius of the disk is r by radius of the sphere is r by 3 square plus about this center axis we have to find out. So plus m by 27 into 2r by 3 square. You subtract the 2 and you will end up with the moment of inertia of whatever is remaining. Do we get this? Yes or no? What is the doubt? Do we have any doubt?
No, sir.
How did I get m by 27?
That mass density into volume is equals to mass. So mass is directly proportional to r cube.
So if it is a volume, if it is a sphere, mass is proportional to r cube. If it is a disk, mass is proportional to r square. So in that case, it was m by 9. In this case, it is m by 27. We understand this?
Yes, sir.
Yes. Okay. So once you get this, you can just subtract it. You will just employ a bit of calculation. Remember, if such question comes, they will be calculation specific. If you make a mistake in calculations, the entire answer will be wrong. So if this question comes, be very careful because it requires calculation and you can make a mistake in calculation. Okay. But this can come. So I told you. And now we move on to the next heading, which is torque. What is torque? Torque. What is torque? Torque is the turning moment of a force. Turning moment of a force. It changes the rotational motion of a body. Changes the rotational motion of a body. It does the same job. It does the same job in rotational motion. Rotational motion means Rm as what? It does the same thing in rotational motion as what is the counterpart it has?
Moment of inertia.
In linear motion, we have velocity. In rotational, we have angular velocity. In linear motion, we have acceleration. In rotational motion, we have angular acceleration. In linear motion, we have mass. In rotational motion, we have moment of inertia. In rotational motion, we have torque. What is the counterpart in the linear motion? No one knows this?
Sir, is it tension?
No, it is not tension. Keep on saying all the names that you know. One of them would hit. It does the same job in rotational motion as? It's also written right now in front of your eyes and you have written it. Yes, I'm waiting.
Linear velocity.
Very good. Torque is related to linear velocity. Then what is angular velocity related to? Torque.
Yes, sir.
Torque is related to linear velocity. And this is what I've heard for the first time in my entire life. It is doing the same job as force in linear motion. I don't know how difficult it is to understand. It is already written here. But we don't have eyes and we don't have brain that we can see and we can understand. It does the same job as force in your linear motion. You've said everything apart from force. The turning moment of a force is represented by the letter tau. It's a vector. So if I don't tell you anything, something, you just don't know nothing about it. What have you done for the past 2 years? You don't understand that torque and force are similar quantities. And I've written it's a turning moment of force. It's a vector quantity. And this is also an axial vector. This direction is given by an axis. The SI unit is Newton meter. You can find out the dimension, I think. This is what we must know about torque. It's the turning moment of a force. Please remember, whatever we have done in linear motion, same things are going to come in rotational motion. There was displacement. Here it was angular displacement. There it was velocity or linear velocity or tangential velocity. Here it was angular velocity. There was acceleration. Here it was angular acceleration. There was force. Here it is torque. There was mass. Here it is moment of inertia. Same. Does it take rocket science to understand this? No, it does not take rocket science to understand this. I can tell you that answer. Torque, turning moment of a force. Now, when we talk about torque, there are two types of things that are sometimes asked. Sometimes they ask you torque of a force. Torque is produced by a force. Force causes, I will write it. Torque of a force about a point is the next heading. I'll write it here, otherwise you will forget it again. And look at my face. Force causes change in translational motion. Torque changes rotational motion. So torque is doing the same job in rotational motion as your force was doing in translational motion. Now there is a point known as the torque of a force about a point. Now, what do you mean by torque of a force about a point? Obviously, you don't know it because you don't know what is torque. So let me not waste any time into it, and let me go straight away into understanding what is torque rather than beating around the bush. How do you find? Looking for a good diagram that I can get. I'm not able to get. Let me draw it. Torque of a force about a point. This is a point O. And this is a force F. Applied at some point A. Now, how do I find the torque of this force about this point? I draw a straight line joining this point with this. Basically, I draw a vector. This vector is known as R vector. This R vector is the vector drawn from O to A. The torque of the force about this point O is given by this formula. The torque of the force tau is this vector R cross F. It's a vector product, R cross F. That is what we mean by torque of a force about the point. F is the force. A is the point of application of that force. R is the position vector of the point of application of force with respect to the origin O about which you are finding out this torque. So it's better I write it as TO, tau O, torque about the point O. Now, this is a vector, this is an axial vector, so its axis is given by the cross product. It's an axial vector, so direction is given in terms of axis. Now, we may not be interested in finding out the vector, we may only be interested in finding out the magnitude of torque. So let me call this angle as theta. Remember, this angle theta is the angle between R vector and F vector. So the magnitude of this torque, which I simply write it as tau naught, taking the vector sign, can be written as R ka magnitude into F ka magnitude into sine theta, where theta is the angle between R vector and F vector. Do we understand this?
Yes, sir.
Okay. So that is what torque of a force about a point actually means. Now, I can write this formula. If I call this formula as formula number 1, I can write this formula number 1 in some variety of ways. Now, if I just extend this line backwards, this is known as the line of action of force. This is known as the line of action of the force. It is along this line that the force is being applied. Now I can drop a perpendicular from here to here. So if this is R, this part becomes R sine theta. Yes or no? You can do the math later on. This part becomes R sine theta. I have dropped a perpendicular from here to here. This part becomes R sine theta. So I can write this torque in a different way. I can write this torque tau naught as R sine theta multiplied by F. Or I can write this tau naught as R perpendicular, the perpendicular distance between the point and the line of action multiplied by F. So this is the second way of writing the same thing. Do we understand this?
Yes, sir.
This is the second way of writing the same thing. Remember, what does R perpendicular mean here? R sine theta is nothing but your R perpendicular. Do we understand this?
Yes, sir.
Great. This is one way of writing it. This is the second way of writing it. Now I can do this in a different way as well. What I can do is I can resolve this force into two components. This component would be F sine theta, and this component would be F cos theta. Do we understand this?
Yes, sir.
Now this F cos theta component passes through the point O. It will not produce any torque. But this F sine theta component is going to produce torque. So I can write it like this. I can write tau naught as R into F sine theta. Or I can write this tau naught as R into F perpendicular. This is the third way of writing the same thing. Do we understand this?
Yes, sir.
So, 1, 2, or 3. Any way you write it, you are writing the same thing. This R perpendicular part, let me not use the green pen. This R perpendicular part is also known as the force arm. It's also known as the force arm. So this is what torque of a force about a point is. Torque of a force about a point is, you can also call it lever arm. If you don't want to call it the force arm, you can also call it the lever arm. Torque of a force about a point. Do we understand this? Yes or no?
Yes, sir.
And we shall write the important points about this and write them and remember them. Don't forget them. Torque of a force about a point. Point number 1. This point number 1 here. Torque of a force about a point O vectorly is given by R vector cross F vector. Do you remember what is R vector and what is F vector?
Yes.
R vector is a vector drawn from where to where? O, the point, to A. Point number 2, the magnitude of tau naught, which is simply written as tau naught, can be written as R into F into sine theta, where theta is the angle between what? Theta is the angle between what? Huh? R vector and F vector. Tau is an axial vector. Tau is an axial vector. The direction of tau is given by which rule? Do you know this RST rule, right hand thumb rule? Yes or no?
Yes, sir.
Right hand thumb rule. The direction of tau naught is given by RHT. Great. You can write this tau naught, magnitude of tau naught as R perpendicular multiplied by F. Do we remember this form?
Yes, sir.
Where R perpendicular is known as the lever arm or the force arm or the perpendicular distance between O and the point of on the line of action of force. This tau naught can also be written as R multiplied by F perpendicular, where F perpendicular is the component of force which is perpendicular to R. Do you understand this?
Yes, sir.
This is the component of force which is perpendicular to R vector. Okay. If the force passes through the point of point O, if you're finding out the torque of a force about a point and the force is passing through this point, how much will be the torque? If the force passes through the point O, then how much will be the torque?
Zero.
The torque will be zero because the force arm or the lever arm will become zero. Now, remember, whenever we have said torque of a force about a point, remember bodies do not rotate about points. Body rotates about axis. So remember, torque of a force about a point tau O, torque of a force about this point O actually refers to an axis. Refers to an axis passing through O and perpendicular to both R vector and F vector. Do we understand what I'm saying here? Torque is an axial vector. You cannot find torque about any point. Torque is always, whenever torque is coming, it is always coming about an axis. In this case, the axis is passing through O and it is perpendicular to the plane containing R and F. Do we understand this?
Yes, sir.
Ah. So these are the important points that you must remember about torque. Due to force at any point. Do we understand this? Yes or no? I've just gone above our head saying bye bye, bye bye. I'm going, don't worry about me.
Understood, sir.
I'm going out. Huh? Shall I give you a question now?
Yes, sir.
Ready for the question? That is the first question. Let us see who gets me the answer. You know how to find out the cross product?
Sir,
Do you know how to find out the cross product?
cross product. Yes, sir.
Good. I'm happy. See, simple things can make me happy. So this is the first question. A force of this acts at the point this from the origin. What is the magnitude of torque about the origin? Let's see who gets me this one. They're asking you the magnitude of the torque, my dear friends. Simple questions are going to come in the exam. Please trust me on that. Huh? Do it fast. We don't have time to waste. You're supposed to complete this torque wala thing today in this class. Do it fast. Fast. Huh? What is remaining? This. Fast. Fast. Are we done? Huh? What is the answer, my dear friends? Tell me fast. So long. Shall I do it?
No, sir.
Just tell me what is the torque that you are getting. You can find the magnitude later on. What is the value of tau that you are getting? No one is getting anything. The answer that is given here is 12y
12
minus 14j
plus 16K.
minus 16k. All of you are getting this?
Yes, sir.
Well done. If you are getting this, I will leave it here. You can find out the magnitude. It's not a problem. If this question comes in the exam, they might not ask you the magnitude. They might just ask you the vector. Everyone got this?
Option B, sir.
Okay, good. Shall we move on?
Yes, sir.
This is a very famous question. It has come many times. So give me the answer fast. The faster you give me answer, the more questions I can do. If you don't speed up, I will have to leave some questions and go ahead. A particle of mass m is released in a vertical plane from a point P at x is equal to x naught on the x-axis. It falls vertically along the y-axis. Find the torque T acting on the particle at time t about origin. Remember, this body is falling under gravity. The value of G is G. This body is falling vertically under gravity. We understand this? Yes or no? No, yes?
Sir.
To find out the torque due to gravity. And your time begins now.
Sir,
Yes, bacha.
mgx0, sir.
Well done. The answer is mgx0. Correct. Good. So how did you do this? This question is pretty damn simple. If you can draw the diagram correctly, it is pretty damn simple. Yes or no? So once you understand the diagram, I'll show you the diagram here. This is the diagram and you have to calculate. This is your weight, mg. You have to calculate the torque about this point O. Yes or no?
Sir.
You don't have to find out the value of this R. You don't have to find the value of this theta. What you got to do is just apply the concept R perpendicular. Remember that torque? R perpendicular multiplied by F. Yes or no?
Yes, sir.
Your F is this and your R perpendicular is X naught. So the answer is mg into X naught. We understand this?
Yes, sir.
Now, torque is an axial vector. How will you find the direction of torque? So the simplest way of finding out the direction of torque is, see, this is mg and this is the point O. How is this mg going to turn the body about the point O? So mg is going to turn the body like this. Yes or no? So the direction of torque would be like this. Do we understand this?
Yes, sir.
And this direction is going along inside axis. Do we understand this?
Yes, sir.
Do we understand this, everyone?
Yes, sir.
Okay. Next one. Give the answer fast. The more the faster the answer you give, the more question I can do. Else I will have to boycott some question and go. A particle having mass m is projected vertically with a velocity v naught from the point P on a horizontal ground, making an angle theta with the horizontal. That means that is the question of a projectile motion. Find out the torque of obviously weight about the point of projection acting on the particle when the particle is at the maximum height. These are the type of questions that are in fashion these days. They are more likely to come. Remember, if a tough question comes of rotation, no one will be able to do it in the examination hall. The only type of question that you can do are these. That's why I'm doing so much questions here. So these are the only questions that we can be confident about. Got this? Huh? No one got the answer. Shall I do it?
mv naught square sine 2 theta by 2, sir.
MV naught.
Square sine 2 theta by 2.
That is correct. So we had to find out the torque at this point, the highest point. At the highest point, weight mg is going downwards. So you again apply force multiplied by the perpendicular distance, and this is the perpendicular distance, yes or no? And this is nothing but r by 2. So basically you have to multiply mg by range divided by 2 and you end up with your answers. Remember simple things in life, and these simple things are going to give you a lot of good results. Shall we move on to the next one?
Yes, sir.
Saw what I did now? Oh, the screen was paused. Saw what I did now? R by 2 multiplied by mg. Do you see it now? Okay. This is the next question. Do it fast. The faster you do, the faster I can move ahead in life. Else, I will have to boycott some questions. Question number 3, or whatever the question number is. Find the torque of this force about point O and about point A. So this is O, your origin, and this is A, your point. You have 2 minutes to do this. Do we have the answer, my dear friend?
10
Ah.
root by 2, sir.
Yes?
10 root 3 by 2.
Which case?
Both cases, sir.
Both cases are wrong, sir. First case, you have to find the torque about O. So you can do it in various ways. I will tell you way number 1. Torque about the point O can be written as R cross F. Yes or no? Now this R vector is I plus J. Yes or no?
Yes, sir.
That has to be crossed with 5 root 3 I plus 5J, and you will get the answer. Do we understand this? Yes or no?
Yes, sir.
To find the torque about the point A, you draw the vector from here to here like this. Okay, I have written this point as A. Let me write this point as X. So now, torque about the point A will be this vector, this R vector cross F. Yes or no? And this R vector is simply J cross 5 root 3 I plus 5J. You can do the cross product, yes or no? So the answer is not going to come same. Do we understand this? Yes or no? Just gone above our head saying bye bye, bye bye, I'm going, don't worry about me. We understand this?
Yes, sir. We understood.
Last one on this. Do it fast. Else I will have to say bye bye. This one. Find the torque about point A, O, and B. Yes, bacha, what are the answers here? What is the torque of the force about the point A? What is the torque of the force about the point A? It is going to be
0.
0. Well done. What is the torque of the force about the point O?
Point.
It will be simply 10 multiplied by 5. Yes or no?
Yes, sir.
Anyone got this? Yes or no?
Yes, sir.
What will be the torque of the force about the point B? It is again going to be same 10 multiplied by 5. Yes or no?
Yes, sir.
And the torque would be like this. Yes or no?
Yes, sir.
So once you understand a concept, you can apply it in various ways. Shall we move ahead? We talked about torque of a force about a point. Remember, it was not about a point, it was about an axis passing through the point. Now we can move on to torque of the force about an axis. It is always about an axis, but sometimes torque of a force about an axis. Now, what do you mean by torque of a force about an axis? So, torque of a force about an axis means it is the component of torque. It is the component of torque of a force lying along the axis. It does not depend on origin O, as long as it lies on the axis. Do we understand this? Yes or no?
Yes, sir.
So torque of a force about an axis is actually that component of torque which is lying along the axis. Now there are three cases possible here. Case number one, force is parallel to the axis. Force is parallel to the axis. Now, if the force is parallel to the axis, this is the axis, and this is the force. They are parallel to each other. Anywhere, they are parallel to each other.
Yes, sir.
What will be the torque of this force about this axis which is parallel? Let us say the distance between these two axes is r. What will be the torque of this force about this axis? This is the axis. And this is your force going up or down. The distance between the two is r. What will be the torque of this force about this axis?
R cross F, sir.
It is 0, sir.
R into F.
Torque of this force is 0.
Okay. Yes, sir.
The torque of this force is 0. Do we understand this, or it has gone above our head saying bye bye? Bye
Yeah.
bye, sir. We don't understand it. You can see this door. This door rotates on the one of the sides. If I apply a force up on the door or down on the door, does the door rotate? Does the door open? This is the door. If I apply a force like this, will the door open? Will the door open? Yes or no? Or if I apply a force like this on the door, open, open, I'm applying a torque. Will the force open? Will the door open?
Sir.
No, it does not open. Why it does not open? Because your force is parallel to the axis of rotation. You cannot open a door by putting it like this or pulling it like this.
Yes.
Your lines are parallel. Do we understand this?
Yes, sir.
So it does not open. So if the line is not parallel, then what could be the second case?
Perpendicular.
F is perpendicular or intersecting the axis. F is perpendicular or intersecting the axis. What will be the torque then? F is perpendicular or intersecting the axis. This is your axis, dung, 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 dung. And this is your force. Oops. This is your force. Dung, 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 dung. And if I extend it, it intersects at the point O. What is the torque of this force about this point? About this axis? Yes?
R into F, sir. No.
If you are into F, well done. The torque is also 0. Cannot produce a torque. About this axis also. If I apply a force like this, hey, open, door open. It does not open. If I apply a force on the door like this, hey, open. It does not open. Why it does not open? Because my line of action of force is intersecting my axis. You cannot open a door by pushing it up, pushing it down, pushing it here, pushing it here. Because your line of force intersects the axis. Do we understand this, or this has gone above our heads? Saying bye bye. Bye bye, I'm going.
We got it, sir.
That means, what does it mean? A force cannot produce a torque. A force cannot produce a torque. About an axis. Lying in the what? Same plane. If the axis and your torque lie in the same plane, my dear friends, your force cannot produce the torque.
Yes, sir.
Then when can your force produce torque? No, that means no force can produce torque, right? But force does produce torque. When can a force then produce torque? neither parallel
Nor perpendicular.
nor intersecting. Force can only produce a torque about skew lines. Not lying in the same plane. You have to think of two lines which are not lying in the same plane. If your axis is y-axis, your force should lie in a different plane. So, if you are, let us say, if your axis is, let us say, this axis, y-axis, if it lies in the xy plane, it cannot produce torque. If it lies in the yz plane, it cannot produce torque if it's passing to the same line. So, your force should lie in a plane which is not same as the plane of the axis. So if your axis is this, your force should be like this, away from it, not in the same plane.
Okay, sir.
If it is parallel, it will always lie in the same plane. So it should be something like this and not like this. Because if it is like this, they lie in the same plane. So they should be like this. These lines are known as,
Skew
they are neither parallel nor intersecting. They are known as
lines.
skew lines.
Yes, sir.
If they come like this, they lie in the same plane. But then you move it like this, they lie in different planes. Do we understand this, or this has gone above it saying bye-bye?
We got it, sir.
That is what a force can produce torque about skew lines. A force can only produce a torque about skew lines. And how do I get that value? So if I make two skew lines like this, let us say, let us say this is my axis, one skew line, and let us say dot, this is my line of action of force. Do we understand this? So my force is coming like this, and my skew and my axis is like this. My axis is like this, and my force is coming like this. Do we understand this?
Yes, sir.
Then you can find the force, the torque of this force. What do? Is you find the perpendicular distance, the shortest distance between these two skew lines. And then your torque will come as R, perpendicular distance between the two skew lines multiplied by F. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye, bye bye?
We understand.
This is the only way a force can produce a torque, by skew lines.
Yes, sir.
One more important point. If force, I think we have written it, if force passes through a point, then I told you the torque of the force about the point O is 0. Yes or no? It also implies that torque of the force will be 0. Torque of the force will be 0 for all axes which pass through those points. Do you understand this?
Yes, sir.
This is my force, and this is the point, and this force passes through this point. Whatever axis I draw from this point, I can draw infinite number of lines from this point of all those infinite axes, the torque is going to be 0 because this force is going to intersect that axis at this point. Do we understand this?
Yes,
I
sir.
can draw infinite lines from this point, but if this force touches this point, it will touch those infinite lines. Torque would be 0 because the perpendicular distance is 0. Do we understand this? Or this is corner power is saying bye bye, bye bye, bye bye. I'm going, don't worry about me. Huh?
We got it, sir. We got it, sir.
Okay. Well done, sir. Normally, you will not encounter force about an axis, but just to make you understand, this is one very famous question that comes. Question number 6 or 7. You have to find the torque of weight about an axis passing through P. Now remember, which is this axis? Whenever I say torque of a force about a point is about an axis, it's about an axis which passes through the point P is and perpendicular to force and R. Do you understand this? In this case, that axis would be passing through point P and into the board or out of the board. Do we understand?
Yes, sir.
How can you find out the force of weight, the torque of weight? This is the weight mg. Now you can resolve it into two components, this one and this one. Yes or no?
Yes, sir.
One of the component mg sine theta will pass through this point. It cannot create any torque. Yes or no?
Yes, sir.
The other one will be mg. This will be mg sine theta. And the perpendicular distance between these two axes is r. Yes or no?
Yes, sir.
So the torque will be equal to
MG sin theta into R.
mgr sine theta.
Yes, sir.
Do we understand the meaning of this?
Yes, sir.
Note this down.
Done, sir.
The next heading is couple. And this is not the couple that we normally think of. This is the couple of force. What is a force couple? So it is a pair of, a force couple is a pair of forces of equal magnitude but in opposite direction. Do we understand this?
Sir.
But in opposite direction. Now, if you look at this line and if you look at this line, this is the line of action LOA, line of action of force 1. This is LOA of force 2. The line of actions are different. Do we see this?
Yes, sir.
Line of actions of these force are different. If I talk more, the net force acting on this system will be 0 because the total force is 0. Yes or no? One force act like this, other force act like this. The total net force is 0. Yes or no?
Yes, sir.
But the net torque is not zero. But talk about the net torque is not zero. In fact, the net torque of this couple of forces can be given by this formula F multiplied by 2D. Where what is F and what is 2D?
F.
F is the magnitude of force and 2D is the distance between them. Do we understand this?
Yes, sir.
These are the important things that you must remember about a torque or a couple, a force couple. Have you noted this down?
Done, sir.
If you want to write it in better language, this is a pair of forces of same magnitude acting in opposite direction with different line of action is known as a force couple. What is the torque due to a couple? Magnitude of one force multiplied by the distance between their line of actions. Do we understand this?
Yes, sir.
What are the important points that you must remember? I've already told you that. Again, I will give that to you in writing. The second point that you must remember, a force couple does not exert a force, but it exerts a torque. Yes or no?
Yes, sir.
And how much is the torque exerted by a force couple? If I give you example of a rigid body, now we might encounter this force couple in some cases where forces are going to act. So remember, if we have a rigid body and this is the two forces acting on that rigid body, what will be the net force on this rigid body? Net force will be how much on this body? Zero. Yes or no?
Yes, sir.
But what will be the net torque? It will be F multiplied by D. Do we understand this? Where D is the distance between the two forces.
Yes, sir.
Okay. One more point you must remember, and that we will use it. And it comes from this understanding. Now, when we say that this net torque is F into D, remember this net torque is about any point in the universe that you find. So if the net force acting on a body or a system is zero, if the net force acting on a system is zero, the net torque is same about any point.
Okay, sir.
Do you remember this? If the net force acting on the system is zero, net force acting on a system is zero, what does that mean? That the system is in translatory equilibrium. Do we understand the meaning of translatory equilibrium?
Yes, sir.
It is either moving with a uniform velocity or it is at rest. Translatory equilibrium.
Yes, sir.
Then the torque about any point would be same. Now you can combine these two. If the force acting on any body is zero and torque acting on any body is also zero, then the torque acting will be zero about any point. Do we understand this, what I am saying?
Yes, sir.
I will write it again. If F net is zero,
Then torque is
then the body is in which equilibrium?
translatory equilibrium.
The body is in translatory equilibrium. Then that implies the torque will be
Same at any point.
same at any point. Second case, if F net is zero and also tau net is zero. Now tau net zero means what? Tau net zero means the body is also in which equilibrium? rotational equilibrium. F net is 0 means the body is in
Translatory equilibrium.
then I can say the torque will be 0 about any point in the universe.
Yes, sir.
Do we understand this, or this has gone above our head saying bye bye, bye bye, I'm going, don't worry about me, I'm out of here? So there are two types of equilibrium. Remember, we are in this chapter. We are in this chapter where we are doing rotational thing, and whatever we are doing in rotational, the same thing we had done in translational motion. In translation motion, when we said force was 0, the body was in equilibrium. Which equilibrium were we talking about?
If F net is 0, it is translatory equilibrium.
We were talking about translatory equilibrium. If the torque is 0, the body is in rotational equilibrium. If force is 0 and also torque is 0, the body is in full equilibrium, whether it is translatory, whether it is rotational. Do we understand this? Yes or no?
Yes, sir.
This table might make you the point very clear. Forces are equal and they act along the same line. So in this case, net force is 0, net torque is 0, the body will remain stationary, it will not rotate, it will not translate. If it is initially at rest, it will remain at rest. If it is initially moving, it will keep on moving. Do we understand this?
Yes, sir.
Second case, first listen to me, then write. We just keep on writing. First listen, then write. Forces are equal but does not act along the same line. So one force is here and the other force is here. Net force is 0, but net torque is not 0. The
Yes.
body is going to rotate.
Yes,
There
sir.
is torque.
Torque. Yes, sir.
Case number 3, forces are unequal but act along the same line. So the net force is not 0, but the torque is 0 because they act on the same line.
Translation.
Here the force is acting along the center of mass, so it does not rotate also. Do we understand this? Forces are unequal and act along different line. Both the things will come. Basically, what we mean to say is, if the force is 0, the body is in translational equilibrium. If the torque is 0, body is in rotational equilibrium. If any of them is not 0, that equilibrium does not exist. Do we understand this? Okay, I'll give you time to write this. The bottom line is very simple. Force 0, translational equilibrium. Torque 0, rotational equilibrium. Both 0, equilibrium. And that is the topic that we are going to do in the next class, equilibrium. So what we must understand about equilibrium? Now, since we have done this, what do we understand by equilibrium now?
Equilibrium.
When I say a body is in equilibrium, what will that mean now?
F net and torque and force are 0.
When I say the body is in equilibrium, it will mean that F net is 0
And torque is also 0.
and the torque is also 0. F net 0 means translational equilibrium. Tau net 0 means rotational equilibrium. Do we understand this? Yes or no? That's it. What is going to start in the next class about equilibrium. And once we are done with equilibrium, we'll move on to rotation. Right? Do you understand this? Yes or no?
Yes, sir.
Chalo then, I will wind up this class here. Please, when you come to the class tomorrow, please go through what we have done today. Yes or no?
Sure, sir.
Are you doing the exercise that I have sent you?
Yes, sir.
Keep on doing those exercises. Everything is given in sections and subsections. We have done till moment of inertia, so all the questions of moment of inertia should be done from your side. Can I expect that?
Yes, sir.
Okay, then I'll see you tomorrow, and let's see. We have taken some steps. Once we are done with this, we will move quickly, because once you understand the basic, the only other term that you have to understand is coming after this. Once you understand these terms, I think we would take giant steps. Take care. God bless you all, and please study and
Yes.
apply your brains. Okay, we are doing a lot of hard work. If it doesn't pay off, it's not good.
Yes, sir.
Take care.